What's going on, everybody? Welcome back to STL Sunday, 3D Printing Sunday, whatever we're calling it. Today, we're doing a mix of things. We're not just doing 3D printing per se. Make sure that everything's working, audio's going through, everything seems to be all right on my side, so hopefully everyone checks in. Today, my plan is to work on something, it's going to be a no prep item, but the process that we're going to use, I think, is going to be something that's going to carry through to almost anything. Someone's messing with me and saying no audio. Mike J. Of course it's Mike J, the troublemaker. So what we're going to be doing is I have my no prep car here, but as you can see, this body, this is the desert rat body that Associated sells with the DB10. This is not a legal no prep body. However, I've got one here that is. This is the Proline CUDA. So what I'm going to do tonight is we're going to draw up a rear wing for this. Now, the process that I'm going to use and why I say that it'll be applied to multiple things is that we're going to make a cardboard template, and then I'm going to show you just kind of an easy way to get you from cardboard to CAD. CAD people often call cardboard aided design because some people don't like computers, but this I think is a good way to get you thinking from one way to the other. A lot of people can think better with a physical template than they can when they're just trying to draw on a screen. So that's what we're going to do. We're going to take our body here. We're going to make some kind of rough cardboard templates, and then we're going to do a simple way to take them from that template to CAD without having to do like a scanner, because or just taking dimensions. We're going to kind of cheat a little bit. So that's going to be the plan. And this, I think, will be helpful for some of you guys who are, you can have an item there in front of you, and especially if you're trying to get into 3D printing, you can kind of cut an item and go, okay, I want this, but I want to 3D print it and add some things. This will be a good transition from there. So let's see, everyone checking in. Did I decide on a color for that one yet? I think that I'm just going to paint this. So guess what color it's going to be? Probably orange. Orange. I'll probably throw some black on it, and we're just going to run it. I've got my electronics installed. This truck is a runner now. I've got the Tekin RS Pro installed. I've got the Tekin Eliminator 4.5 installed. Weekend? No, it was it was Tuesday. It was election night. I designed up and cut a carbon fiber receiver tray. What's that called? ESC tray that bridges that. Super quick design. Threw it in Fusion. Got my tool pass done. Cut it out of carbon fiber on my Stepcraft. So this thing's ready to go. 100%. I could run it just like this, but that body not legal. So that's what we're doing. That's where we're at. But we're gonna be ready to go. I've got some other parts on the way for this thing. A few other things to work on, but like I said, the Proline CUDA body is our subject of the night. I'm going to throw body clips down there so I don't lose them. I've got some bubbly here and hot tea, but more importantly, I have an empty bubbly box because I have found that the cardboard on soda boxes or bubbly is just the perfect cardboard for templates. So there you go. That's why we have this here, not just because I love bubbly. So today, a little bit, we will get into CAD quickly, but we have a brief detour between then and now. What wheelie bar was that? That was like that was a RJ Speed wheelie bar that I took and modified and made fit. I've got an R Designs wheelie bar mount, and I think I actually have a Drag Concepts mount on the way as well. So I've bought a bunch of parts for it. I bought the whole Drag Concepts rear anti-roll bar shock tower deal, everything. So let's cut some bubbly boxes up. Want to sell that trophy rat body? No, I kind of like it. I kind of like it. I think I'm going to keep it. Because it might be fun to just to see the difference of running the narrow body versus the legal no prep body. So we're disassembling this box. Where's the seam? There it is. Ah, nice cardboard. We're just gonna, I'm gonna cut out a flap of this so that I have it. And we can toss the rest to the side for the moment. So we got two pieces that we really need to make. Oh, hey, I appreciate it. Corez09W, $10 donation. Always nice on the Sundays. Oh man, go not orange on the CUDA though. Maybe orange wheels. Whew, that's a bold choice. Here's the thing. I have 15 cans of orange paint and that's about all. Maybe some silver, but my variety of paint, not very vast. So we really have, like I was saying, two pieces that we need to make. One is the deck lid, the actual wing portion, and then we need to make the side portion. And we have to either decide if we're going to come off of the side or if we're going to stay up on the lid here. If we stay up on the lid, it's a little bit easier. But if we go off of the side, we don't necessarily have to do the mounting feet the exact same way. So let's just see what we think. So I think I have let's see. I have a second camera angle, but I don't know if it's going to be any better. We'll switch to that if I need a close-up. Would it be 3D print or CNC cut? So that's another point that I wanted to talk on, and thanks for that comment. So I think that the best material for this, what most of the drag guys use, is Lexan sheet that you can buy at the hobby shop. But one thing that people don't use their 3D printers for enough, obviously most people don't have CNC machines. I get it. I'm not saying that you need one. But you can take whatever we design or whatever you design and then 3D print yourself like a perfect guide. So you can you could reproduce them. Make some money with your 3D printer. Design up a drag wing, print yourself out some templates, and then you can attach that to your Lexan, cut them out, and you could probably reproduce drag wings. People that make and sell these things sell them for $20. You can do that. You'll pay for your 3D printer in no time if you just find some hustles. 3D printers, they don't have to just be for the parts you use. You can make tools with 3D printers, and it's just fantastic to do. I do that with mine for all kinds of things. My stamps, my metal stamps, like so many things you can do. So just get a little creative and go for it. So we are going to grab a pen. For me, I will be cutting mine out on the CNC because it's cheating and I have it here. Don't hate, but so let's also grab some tape. So I'm going to kind of decide where I want this wing to start at. And I think I want it to go, or at least the side panels. I think I am going to have them go onto the side of the body rather than up on the deck lid. But I'm going to try and draw a line from one side to the other, squaring off of a couple of similar points. There we go. Okay. So that's just some Tamiya tape. This body is the Proline CUDA for someone who can't see it from that weird angle. But the reason I did that is I want to have a constant reference point when I take this off, put it back on, take it off, put it back on. I want to always go back to that same spot. That is the reason for that. Now let's also put a lower edge on there. Now I do still have the overspray film on here, so I don't need something like that. What if I just go, that's at about 90. And put a line across the back. I'm going to measure up from the deck again. Okay. So that's how much I'm going to put onto the side itself. Okay, something like that. 3D printers are not that that is true. 3D printers are not that expensive anymore, especially. And then here's the other thing. For what we're going to do, if you don't even have a 3D printer, you can do this. You can make your cardboard template. You can convert it to CAD, and then you can print yourself out paper templates that are the exact same over and over and over. You can put those down on your Lexan, and then you can make enough of those by hand pretty easily to buy yourself a 3D printer. Like, you can make money in the hobby. Just go to a local hobby shop and say, hey, I've got 10 of these drag wings, and they'll, be like, retail $20. I will sell them to you for $10 each. Like, and just, if you put them get them in a decent bag, print yourself out some header cards at home with just a very basic, like, you can hustle. You can do it. You can pay for your hobby with some of this stuff. It's all time and effort. That's the big thing. So I'm going to make some reference marks. Here's the top edge of our fender in the front. Here's the back edge of our body back here. So I'm kind of estimating the curve. So I'm just doing like a quick sketch estimate of where I think that the curve of the body is. This isn't all that important. All I know is that I want it to go, significantly higher than that in general. So it just gives me an idea of what to do. So that's a start. Now I kind of have where that back edge of the body is. So I know that from that point, I want to taper up. I don't think I plan on having much. Actually, let's say that we want to go out 10 millimeters first, and then we're going to taper up. So I just want to do it at a 45. So I'm going to measure 30 back, 30 up. While it's not super important to nail our dimension or our angle, it'll help me get a little bit closer as we go, especially when we go into CAD. This isn't going to be super exact. I'm going to just keep going through here. Excuse me, sir. Josh said you would buy these wings for $10 a piece. I'm just saying, if you go into your hobby shop, like, hobby shops are there to make money too. So I know where my body line is here. Again, I want to kind of match that angle. So I'm just kind of dragging my ruler at what I felt like was a consistent. So there's that. Now this is pretty good size. Now, if you can't see kind of like that, like it tapers in quite a bit. So we actually need to it needs a bend above that body line to start to bring it flat. And we're going to I'm just going to grab a scribe of some sort. Make a mark, follow with a pen. But if you scribe cardboard, it bends a lot easier. But as we do that now, that wing much flatter. Now it still has a bit of an inward taper, but I'm not as concerned about that. So the other thing is that I need to make a couple of body holes in this area where I know the, like since I sketched out approximately where the body panels were, I know that I can make 2 holes in that and comfortably have them fall within the body area. I'm going to space them out as much as I can, keep them so they're not too far up towards that line, but I want them spread out for as much support as possible. So I'm making some very, very basic adjustments. Okay. All right. I'm not gonna, this little extra thing up here, that was actually just from the design of the bubbly box itself. And I like it. I'm keeping it. A design feature that was unintentional, but is staying. So this is all I'm doing for this side. This is all the further I'm going to take a paper template. Let's, hey, Jasper Hobbies, one of my old hometown KC guys. What's going on, Philip? Great view, man. I will have to catch the rest in the morning. Have a great, good seeing you, man. Someone here helped talk me into a printer over a new RC. I regret it zero. Enjoy the design and creating parts. And Video, I see you posting stuff all the time. You dove right in. You've only had it, what, a few months, couple months, something like that, and you're killing it with stuff. You're doing great. So it's exactly it. It doesn't have to be crazy overwhelming. So, all right. So we did one side panel. Now, I put this line across the back of the deck lid. That's not how far up I'm taking the actual base of the wing. That was just how far I wanted to take up this portion. So I'm going to do another set of lines now for that, but I'm going to use some wider tape so that I can do some measurements and not have to worry. So we're going to drop that here, kind of mid deck lid. Cut off some excess. There we go. So now let's make a couple of marks based off of that tape line that we had. I'm going to go about 35 millimeters back. Put that right at the trunk line. All right. What hotkey is tape? Right. We're going to get into the actual CAD portion soon. Don't worry. But I'm telling you, I know a lot of you guys are way more comfortable working with cardboard than CAD, but either way, it's still a great help in the design process. So Any skill you have can be applied. Just use it. Press X for construction. We're not far off. Flying through this so we can get... This isn't going to be the prettiest version of this. We're just going to kind of bang through it so that we can get to where we need to be. So the one thing I need to do... Well, you can tell like my cardboard isn't quite as long as it needs to be, but really I only need half. So it kind of is as long as it needs to be. I've been on the fence. You make it seem to look easy. I've been doing it a long time, but honestly, it's one of those things like don't overcomplicate it at first. Just kind of jump in and do something stupid and small and just feel the accomplishment of drawing something. Like, and then just build on it. Just every time you can do a little bit more. So don't worry about like, I'm not here to impress anybody. Just build something and have fun and then feel accomplished and you've learned a new skill and make it make you money. It'll do it. You can do it if you want. Like it's something that in the end could make you a ton of money if you really want to just keep going. So got one line there. We're just eyeballing some things. I'm going to make a couple of reference marks on the cardboard and the body so that I can take this off and line it back up and everything will still be accurate. So you can see here, you see that black line? That's on this cardboard and the blue tape. So I can, and same down here on the bottom, on the card. So I can take this off, make the cut, and then put it back. Oh, I do have on a Proline t-shirt too. Not planned. All of my shirts are RC shirts, so it's just the luck of the draw. All right. Cut off that. So, where did that part go? Right. Now, one thing I'm noticing is that I'm going to make the mark for the back edge. So now that distance is 64 millimeters. I'm going to go over here, make a mark at 64. Okay. So I'm also going to kind of write that dimension, 64 millimeters. Since I measured that one, I can know it. It'll work as a reference when we get there. Dawson says, just got on. Looks like a CUDA body and cardboard. Yes. We are going to start by making something simple out of cardboard. And then I'm going to show you kind of some easy ways to take and convert it from cardboard aided design to computer aided design. CAD board, a old schooly common terminology. Let's see, we're gonna line up our hash marks again. Put that down. Do need to mark the... Okay. So that kind of gives us an idea of... Now, the only other thing I need to do is we're going to put a kick up in this wing in the rear section. So that's going to start at that line that I just drew, and it's going to kick up from there. But for the most part, we can make any of those adjustments in the actual model that we draw on CAD, because it's going to go up at 45, and I'm basically going to have it follow this rear edge of our bubbly. So should not be too terribly difficult. I'm just looking at a couple of things to make sure that our angle works right, because we do want this to not have too much of a down. We want to have it pretty flat. So something like that. Yeah, I think it's going to be all right. We're going to be... The wing itself is going to be kind of flat off the back rather than falling down like the back side of the body. Pretty happy with this. Like I said, not a lot to this part of it. Just throwing some stuff together. I'm going to do some cheating geometry though. And we're probably about 3 minutes away from starting to take this into CAD. Oops. So this is going to be a wing line. This is the trunk line. Just making some notes on here. The trunk line, and then the upper one, wing line. So then we're going to note this is the start of, what do you call it, rear lip? Rear lip, there we go. And the only other thing, so, oh, not the right way. We're going to do like a 20 millimeter rear lip. And then we're going to cut this off. Get rid of all this extra cardboard that we're having to throw around. Line there. And we are almost ready. All right, get rid of the garbage. One last thing we can do is I'm going to take so 210 millimeters wide, that's 105 to a midpoint. And I can't really do it at the bottom part because it can go wide enough. But it should be 234 millimeters across the bottom. At the base. All right. I wrote that on the tape that I planned to peel off, so we're just going to bend it under instead. Ready? Now, does this help for top end or is it for looks? So the guys that are running, the wings are actually very important in no prep. Not by my own experience, but by the guys that are going fast. They've got, some guys run huge wings. Guys play around with the wing design a lot. It's a nice thing if you have it in CAD, you can make your adjustments to your template exactly, and then all of a sudden, you have repeatable things that you know exactly the dimensions or things you're changing. As to if you're making them by hand or you're buying one, you're either stuck or you're just winging it every time. So here is the not so fancy part. We can do this separately or all at once. Let me tell you which way that I'm going to do it. We are going to put these items next to a ruler and we're going to take a photo. And we're going to bring that photo into the computer. I'm going to go zoomed in on my phone. So we're going to keep the cardboard pieces because that's something we will reference, but most of what we need now is going to be done. So I'm going to transfer these over on my phone real quick. I just use Google Drive. You could email them to yourself, whatever is easiest for you. Or the other thing that I find myself doing is Facebook messaging myself. If you didn't know that was possible, now you do. Sent and delivered. So I'm going to open up my Facebook. And save the photo I just sent myself. Save image. Hold on just a second. 3D printing. Wait. Okay. Are you going to check those messages for a change? Oof. You don't want to see the number of unread Facebook messages I have. They're not, I check the ones on like my Harley Designs page, but my personal Facebook page is a disaster. Like, well, and the fact that like I never check the requests. So yikes. All right, now we need to Fusion. The one that we're all so familiar with. So here's our blank document. This is where you'd bring. So now we're going to go over here on the top right area. We're going to hit Insert, Canvas. And we're going to insert from computer. 3D, what do I call it? Wang. And we're just going to drop it onto that and hit. The only thing I'm going to do is I'm going to rotate it 90 degrees. 90. Now, that's like upside down, but whatever. So here on canvases now, we can do a, oops. We're gonna drop the canvas down. We have wing, and then we can right click on it and go down to calibrate. So this is where the photo thing makes sense. So we're gonna click on a point like right here at the edge of the ruler. And then we'll just go to the end of the wing area. So about here. And we know that that is 220 millimeters. So now we have a scaled drawing of what we just did. Now you have to take into account that there's things that you have camera perspective and things like that. All of those, it plays a part in it. But what we're doing isn't so exact that we have to like really worry about it. So there you go. That's I said it, I've covered it. Now we can move on to playing with cars. So I created a sketch on the front plane, which is the same plane that I inserted this photo onto. Now you can see that my orientation isn't exact. If I want to edit the canvas, I can kind of, let's see. Let's see, go -1, -2, -2 gets me pretty close to square. Hit OK. We're going to go back to that sketch. I think we're still in it. That's okay. So now let's just do a little bit of sketching on top of our parts. We got the bubbly box notch at the end. It's my new signature design feature. Now I'm going to, normally I would always draw from an origin point. I didn't in this case, but I'm going to kind of cheat a little bit. We're going to zoom in. I'm going to move this corner somewhere that I like it, say like that. And then I'm going to right click and hit fix. And that fixes that point, but I should still, yeah, I can still move the lines that are associated with it. It actually has a 90-degree, which I'm okay with. We're going to leave that. So we're going to dimension the rest of these things. 24 is fine. We're going to dimension the angle. Let's go 135. That was supposed to be a 45-degree. 135 is a complementary angle to that. So I got it pretty close. Not exact, obviously, but we're going to dimension that. 34 gets us close to where we were. I'm going to make that a horizontal line. You can see that I was doing everything by hand, so it's wouldn't graph paper be better? Graph paper is great in some ways. It's great because you can get those square lines and things like that. But the nice thing about cardboard is that it's got some rigidity to it. You can make bends and it will keep them. For that reason alone, I find cardboard to be way better than graph paper. For that reason. Now you can see, like I was talking about, this not exactly square. If we adjust this 35, let's go 34.5. Kind of split the difference between the two ends. Now I'm going to do a parallel constraint between this line, that line, that line, and that line. 88 millimeters. And 15.5 is fine. We're going to try and dimension from some fixed points. It's weird that it all shows everything being defined. Oh, it's okay. Oh yeah, because I did parallel constraint. Plus, who has graph paper laying around? Everyone has empty 12-pack. I'll give you that part as well. But I'm telling, like, for the being able to bend it and work with it alone, it's worth it. All right. Okay. So the other thing I'm going to do now is hit L for line, X for construction. I'm going to put in that body line that we had there. And then I'm going to make a little adjustment there, but well, that line should have been a horizontal line anyway. So there we go. I'm going to dimension where that 26. Okay. You can see we weren't too far off on a lot of our level and angle things. I meant graph paper to take a picture. Yeah, but I mean, if you're trying to get that, I don't know that it really matters. It's so easy to just kind of rotate things. You know, I don't think it's one of those things you don't really need to overthink. Just get through it, and then you'll be fine. I'm going to I fixed that construction line. So now we're going to hit finish sketch. I'm going to turn that wing off for a moment. Now this whole thing, we can extrude, and what is a lot of Lexan, you can buy like 0.040 inch. Gives you that. I'm going to go back in, turn the sketches on. So our bend line was at that body point. One thing we can do right now if we want to get our perspective back, we can grab the, hit the move command at the top, go down, select the body. Let's see. Front. We kind of have this thing upside down, so I'm rotating it 180 degrees. Okay. It doesn't rotate our sketch too. Never mind. We're going to leave it how it was for a second. I'm just going to work in upside down land. So I'm going to do a sketch, select that face again. Should have rotated my sketch the first time, but hit P for project, and I'm going to grab that line that we did before. And the reason I did that, I'm going to hit finish, turn off the first sketch, sheet metal, because I'm going to kind of consider this like a sheet metal part. We're going to just select that item, hit OK. Just basically turns it into a sheet metal component. Nope. I lied, it did not. I thought it would convert it. I'm wondering, can I just... No, it's only doing it as a flange. Boy. I need to add a bend, not add a... There we go. Allow stationary side. Okay. We can do this a different way. It's okay. Create the thing we just created. Hit OK. Oh, allow me to do that. There we go. 0.040 inch. We should have just done that the first time. I'm just going to actually delete what I did. From here, now we select it, 0.040 inch. There. Should have done that the first time. It's okay though. Now create a bend. P for project. I need entities. Select just that. Hey, Isogen, thank you for the donation. Can we have a Suki cam during 3D Printing Sunday, please? Yeah, she has been a pain in the butt today. Stationary side. Oh, this is what not. I don't know why this thing is not. Okay. It is just not wanting to cooperate. This is my fault. I can do this without creating the actual bend, but it's just a lot nicer to show it and visualize it this way, but we can come back to this too. It's okay. Like, this is the important part, at least. We're going to turn that back off. I'm going to turn the wing thing back on. So now I can create the next. You know how computers work when they want to work. When they don't want to work, I know. Always. Always a thing, but it's okay. We will continue on. So I am going to, for one, I'm going to go straight up. We're only going to draw half of this wing since you can never be totally sure. There's that. Now the other thing, I guess I could just learn at this point is we'll just do this one how I would normally do it and just do a base, the base sketch first. Those two, making sure that all these lines are vertical. I'm going to fix that line so that it does not move. 65 millimeters was how long that was supposed to be because we wrote it right. Oh wait, 64. You can see how that differs a little bit from what I actually drew and what, now that could be a difference between where I marked with a Sharpie pen and where I actually drew, and then how my sketch scaled, but it's okay. So we're going to dimension from here to here. We're just going to leave it at exactly how it was shown. We're going to make sure that's at the center and hit fix. Oops. Fix. Now everything on that is also .040 inch. Now, off the back side of it, we would do our I swear to God, now this thing doesn't even want to do what I want it to do when I want it to do it. Well, that's just ridiculous. Cancel that. I'm going to do a new component within it. There we go. Let's see if that allows me to do it. Fantastic. Bend sold separately. I guess this thing just sometimes creating multiple bends in one part. I've seen that be an issue before, but it's just not normally some. I'm displeased with this. Now it works. For some reason, it didn't. I created the extrude in a sheet metal way. I don't know, whatever. I fixed it. It didn't want to consider it sheet metal. So that was going to be 20 millimeters. So we've got both of those now. Turn on that body. What a pain in the butt sometimes. Stupid technology. Let's see, front, we're going to rotate that down 90. We're going to call that good for now. I'm going between working on multiple components right now, which is sometimes, let's see. So we need to rotate that 180 first, then 90 to start, but that's not our final, because you can see this thing is actually at a bit of a skew here on this side. It is not 90 degrees. So if I bring that over, I'm going to put these things close to where I wanted them. About like that. Now I'm going to move the pivot point to that corner so that when I rotate, I can check. Let's see. Actually fits pretty well right there. I'm going to change that again. 10 degrees, hit OK. And then I'm actually going to just move this thing over about like that, so that there's no, or less interference at least. So you can see though that we've got this outer interference, and we're going to fix that. And then mirror both of these things. Pivot, pivot. But we're far from done. Well, the other thing is that we didn't, I didn't put the bend in that top part. That was the other thing. We're going to go back, working on this one. Turn that off for a second. This one, sheet metal. Can I hit? Modify. No, it already does think it's a sheet metal. Okay. Capture position, that's fine. No, it doesn't. Should I buy a cheap or don't? What? You must be talking about a 3D printer. If you're looking to buy a 3D printer, just get the Ender 3, whatever, and it will just get you what you need. It does the job. So we're going to turn off the, I don't know why I didn't want to let us do both, but that's okay. we are going to make a cut along. I'm just going to trim off the end of that wing so that it matches. Something like that. That way when these things are both done, everything should work fine. Okay. We're going to do a couple of, we're going to mirror this body about that face. I'm going to do new body for now, because if I hit join, it's going to join that outside one as well. But after we did that, I can combine the two. So that will give us our rear wing deck in total. Now, I haven't put any screw positions on this yet. The other thing is that normally these wings, you would like them to be connected to these side panels, both for rigidity and strength overall. The easiest for this one, we have two options. We can go downward off of the back and put a flap on the bottom side. And I think that will be the easiest way to go. We kind of continued off the back side of the body, which if you remember, we've got this area right here on the, So in this area here, it's past the body. We can make a little area that will allow us to connect to it without much concern. Now, some of these drag guys run a much taller wing than what I'm showing here, but this is, again, more of a thing you can do in principle. So we're going to make sure we're working on that component. Go back to sheet metal, add a flange. We can select that, drag that down. We're going to do this one as on this right datum over here. We need the bend position to be adjacent. And then our bend radius, override rules, bend override. We're going to select that. Radius, we're just going to do, a 0.5 millimeter. It keeps it super tight. With Lexan, you can kind of, things move and bend out of the way enough that it's not too much of a concern. We're going to go down 10 mil total. I'm going to make sure that fits, which I believe it should. Yeah, we've got 17 millimeters, so we're going to hit OK. Then we're going to do a sketch on that. And we're going to, we know that we can kind of go out here with a 3 millimeter hole. I'm going to put a larger, say 8 millimeter radius around it. I'm going to make that larger radius tangent to the bottom. Five millimeters in. This will make a little bit more sense in a moment. Hit P for project to grab that surface. Vertical line, hit X to turn it to construction. Hit the mirror, grab that line I just drew, mirrored about that. Hit OK. I'm also just going to hit P for project to grab that whole surface. So now I can go in, do a cut, and we're going to take all of that back off. All the way to there. Oops, one thing I forgot is also to make the hole. So now we've added a tab that gets bent down. And we can do, we're going to go up to the top hit mirror again. We're on the drop down, we're going to go from bodies to features. Then on the objects, we're going to go down and we're just going to select down here in the history tree. We're going to do both the flange and the cut. Mirror plane will be our, ooh, is that going to work? Nope. Cancel. I'm going to just drag my, we're going to delete the mirror. No. Damn it. I've got to make my mirror plane by hand. This is what sucks when you don't do things based on an origin. Your planes are not set in the right spots. Point. Now I could have tried to move it, whatever. Finish sketch. Create a plane. I'm going to select that. To object. There. Now we're going to do my mirror. Features. Bend and the cut. About that plane that I created. Of course it doesn't want to work. Nothing wants to work for me tonight. Let's just do the flange. It's nice when it doesn't work just right. Slows it down, you can explain more of what you're doing. Okay, you sure have a rosy outlook. Thanks. It's sure frustrating to discuss though. So let's see. I'm just trying to figure out if I can do this in a way that isn't going to, can I do an edit feature? No, that's always going to be, what a pain in the butt. Can I mirror just the sketch? Let's see. No. I believe that for this reason, I'm going to either have to do it the hard way or redo some things. Neither of which are my favorite options. This is a cheating I'm going to delete that mirror, delete the plane, delete that sketch. This is absolutely not the right way to do it, but it's a cheat if you can't get things to work sometimes. I'm going to just basically cut this whole thing in half for the sole purpose so that I can remirror it. Don't do this, just, you know. But if you have to. Now you've done it in a way that you got what you want. So you can see things are overlapping a little bit with how I created that tab. Again, in Lexan, things move around a little bit. It's going to be off the back of the body. It's going to kind of flex exactly how you want it. When you're making something in CAD that you're going to hand fabricate, things can be a little fudged because you're never going to, things always just work out. It's fine. Don't worry so much. Right? Right. I agree with me. We are to object, will it? No. So now I want to do I want to take this component and I want to, can I create a drawing from it from right here? New drawing from design. Select this item, create new drawing from scratch template. That's fine. A4 is standard paper, almost standard. It's not actually standard paper, but so I'm going to scale 1:1. I'm trying, let's see, will it give me, what I'm looking for is, I want the drawing view. Where's my unfold? Don't save. If we have it selected here and we go into sheet metal, you can hit the unfold button, create flat pattern. Stationary face, we want the biggest flat part, hit OK. And it gives me a warning. Of course it did, because nothing is just. What is wrong with you? This is annoying. I don't. I mean, I see some funkiness going on there. Let's modify the cut we did. We are going to do, let's just play with it. Sometimes you get things that just don't want to work. I think we can do a bend position. We already did that. Flip. I feel like we could do a non-full length. Full edge. Here's where we, two sides. What is that all about? Yeah, let's do. Gonna see if this makes things a little bit easier. I feel like it could be where the possible source of some of my issues are. Okay. No idea where that is coming from. Oh, it's just a relief thing for the bend. Ah, it was that. And I fixed it. Haha. See? So now it made the flat pattern for our drag wing. Okay. Sorry. Steam things popping up. So now this would be what we would take, and we can create a drawing based on that. This has been more frustrating than it should have been. Sometimes live has these hurdles. At the top, we can export into a couple of things. Sometimes you can export to a DXF and then bring that back into a drawing. There's a number of ways you can make this part go from here. Let me see if I can just do a, can I take it from this template? It'll allow that. This is what I don't remember. I usually just, yeah, it does work. Perfect. So you take this, we would make this a 1:1 scale. And now you could print this thing out and have a perfectly scaled file. Sometimes I should work things out further before trying to do live demonstrations. This amateur hour. Steam things? Yeah, Steam is like a program you use for video gaming. For when I video game, which is pretty rare, but sometimes it happens. I think my username is Harley Designs or Harley Designs Inc. I don't know, one or the other. If you're on Steam. So here you would have this. You see output top right, output PDF, and then, oh, did they get you there? You would just, I think you can only print it from here rather than, well, print a Microsoft PDF. There you go. Do it that way, and then you can just print it from there. For some reason, they won't let you export. The weird thing is that mine says non-commercial, but I have a 1-year commercial trial license. So I don't have like some of the other restrictions that people have. I don't know. I think mine's, it's either weird or funky or something is off, but whatever. For now, I have my 1-year trial going and it is fine. So this would be that there. You would save this out. I'm going to go ahead and, will it allow me? No. For me, because I'm going to actually use this, I'm going to export as DXF. Hit OK. Drag wing base. Of course there was a problem. There's always a problem. I will figure that problem out later when I'm actually starting to make this. But you would do the same thing for the side. I think the biggest thing out of this whole thing has been, shows you a little bit about going from cardboard to an actual 3D part. This was kind of a difficult one because you've got multiple angles working all at once. This is probably one of the more difficult, but not crazy difficult. It could get more difficult, especially if you have like multiple bends and things playing in one way. But this one had just angles and bends that just didn't love to work well together. So that's why. However, that was kind of a exercise in frustration. So I think that you guys should come up with something ridiculous in the chat again, and let's draw something fun so that we don't end this one on frustration. So, not another appliance. The appliances are fun and I actually really like those, but I feel bad that I find the most joy making stupid appliances. Something universal. I'm not making a specific bumper mount for an enduro only, like random suggestion. Something, a riding lawnmower. Oh, that's a good one, but it's a lot. I think a riding lawnmower might take us 2 hours. I second the riding lawnmower. Oh man, I don't like, maybe we could do a riding lawnmower if it's not like super awesome. Not side dams too specific. No, we did a wheelbarrow already. A push mower we could maybe do. I think maybe I could get a push mower done faster. I think I could maybe get a push mower. I still say skateboard. jack, a weed eater. That's an interesting one. Floor jack. I feel like floor jacks. The problem with floor jacks is that they're just, to make them the right scale, I feel like they'd be kind of flimsy or just too small. Okay, someone, a chainsaw. Okay, we're doing a mower. Which mower are we doing? We're doing a push mower. We're doing a riding lawnmower. Which one? Skateboard with bearings for wheels. That would be super. That one would be like really fat. We could possibly just do that like quickly, but push mower, push, two for push, riding, two for riding. Who's the next one to say something? Rider, push. Yeah, the push mower would be, or the riding lawnmower would be low red or too rushed. We're gonna do a push mower really quickly. I'm going to push mower. It's still gonna be somewhat low res and rushed, but let me find one that I like. One that's going to be fast enough. I'm just going to go to Lowe's.com. Push mower. We're going to do it. We're going to sort by low to high because the cheapest one has got to be the easiest, right? What's the cheapest push mower you can buy right now from Lowe's? Let's see. Don't forget the bag. Psh, mulching is where it's at. Who wants to bet what the cheapest mower you can get? $117? That's $179. Here you go. Okay. Here's the one we're doing. Whoops. Super basic, right? That's what we're doing. All right, I lost my reference photo. There we go. Okay. Let's knock this thing out. Let's start with the base. We're going to say this thing has got 16-inch, 1.6 inch there. We're going to do put something around it that is, say, 3 millimeters. Then let's do some rectangles about like that. X for construction, make that horizontal, make that 6 millimeters wide. Bring that in just a hair. That L for line. X. This is going to be like the area that, come on. This is going to be what will hold the wheels. And this is going to, I'm doing this because I'm going to basically kind of fillet everything around, because it's kind of like most of these things are all that stamped cheap stuff. So they're kind of flowy, organic-y. And we're just going to do this stuff based on look rather than based on anything else. Let's see that. Go down 4. Now let's throw a bunch of fillets in here to start making these things look like the base. How ridiculous is this going to look in a scale of 1 to potato? That. Is this going to look anything like a lawnmower in the end? Just that. Now let's do these. Something like that. All right, now we should be able to put a radius around the whole top. 2.75, like that. Okay. Don't hate that. And then one other thing we're going to do. This feels totally unnecessary, but we're going to go 0.8. Just that outside, and we're going to go up negative 0.8. Put that bottom kind of, you know how stamping always has that lip around the bottom? Unnecessary. Blade needs to be on a bearing. Dale Nemo is 100% correct. Bearings it is. Oh, let's insert a lawnmower. We had, oh God, it's being difficult. We're gonna, I was gonna go insert wheels from something previously, but 2.5. C for circle. Let's just go 6. Now, let's go 4.5 there. Push those out a little bit. Wheels always kind of go further around and spins when you push it. What kind of gear drive shit is this video? Maybe I can have an attachment at the top. It's a possibility. Height adjusters, you're crazy. Two sides. New body. We need to make sure we bring this out far enough so that the wheels don't rub the body. Let's see how that looks first. Okay. So we're going to pattern, circular pattern. Will that work? No. Bodies. It will not work. What am I thinking? Will it? Am I brain dead right now? We're going to find out because I can't mentally think about why that wouldn't work. Yeah, there's why. Okay. God. Sometimes you just go brain dead and you have to try things. Now we have those. Don't forget the bag for clipping. I'm a mulcher guy. You know, that's, you're either discharging or mulching. Like we're not collecting. I don't know who you think we are. I was thinking I was going to use wheels from something else, but none of those are going to be the right size. So we need to grab those, by the way, to make sure that we can ruh-roh. That's not right. Do I have an, oh yeah, I've got enough in there. 9 mil. We can even go to 8. That's fine. And then we can make sure we mirror that to both sides. That'll be a feature mirror, not a body. Okay, so yes, self-propelled, the whole deal. Now let's draw ourselves a wheel of some fashion. While the blade may be on a bearing in the end, the wheel is not going to be. 15 mil, sure. Why not? Let's just go 4 mil. What do you guys think? Is that too? I'm going to put a tread around this still, but I don't know. Seems okay. Like I said, we're going on 0.5 there, 2 sides. We better just go to 3 on the inside so that these are easy to print. Because I care. Ooh, those are too big, aren't they? Yeah, that's better. Let's do faces, that face, that face. There we go. We're gonna oh, I didn't make that a new body when I made it. There we go. Okay. Is this a lawnmower? This is a lawnmower for no good reason. You are correct. We're making all wheels the same size. I'm sure someone has an issue with that, but that's what you get. We need to make the depressed area that goes around the engine. Something like that, yeah. That's enough. That, and then we'll do another one. That. Oh, we did a motor even, didn't we? We did the, when we did the bar stool racer. We could just use, oh no, that's the wrong type of motor. There you go. Ah, we have to do a different motor. This was like a V twin. Failboat. Undo. Okay. Oh my God. What in the world? So the good news is that I've got a 360-degree view here on Lowe's.com of the $175 engine that. Okay. So Barstool Racer, that would give me a whole reason to fall off. Yes, we did a Barstool Racer. Put an oversized exhaust on it, please. Oh my God. All right, let's do a couple of things first. Well, actually, finish sketch. I'm gonna, before we get too far, we're going to, I'm gonna put a 10 point, let's see. No. I'm gonna do a 15 millimeter hole through the center of this thing. While that may seem large, and it is, I will explain. This is only, we're gonna go -4. That actually, oh, like it's exactly to the top. That's okay. Let's go -3. That's okay then. I'm going to use a 10 by 15 by 4 bearing, which is like the common inner knuckle bearing on an SCX10, SCX10-2, Element, like all of them. 10 by 15 by 4 bearings, super common. But that's going to allow me to use a like really large shaft to go through the center because we're going to make the lawnmower blade spin for some stupid reason. 13 millimeters. That gives us a there. I'm going to draw the bearing just so that I don't forget. 15, 10. I'm going to take that down 4, make sure that's shown as a new body. Okay, there. So now we have a very large bearing. You may have to super glue that in so that it doesn't just, well, no, that'll probably be fine. I think we'll be able to make it work. So I'm going to go with an 11 millimeter bore here. Go 3.5. How far down can we? I'm just gonna go like, go down 2 for now, hit okay. Then we're gonna put our, this type of lawnmower just have one blade, right? Or do they have 2 that are like crossed? I don't know. What do cheap lawnmowers have? Is it gonna show me? One blade. Okay, one blade it is. All right, so sketch on that. You guys ever get sick of just stupid projects and you wish I did something you would actually use instead of wasting your time watching me draw something that's pointless? Maybe we'd have more people join us. It's hard to say. 5. I'm down 2. It's a pretty thick lawnmower blade. Totally agree. Adding these for strength alone. Now, let's do a... can I modify? No. I was going to do it by form, but that's something I'm not very good at, and, you know, I don't know that there's any reason to really try that. We're going to turn off body 1. I'm going to make a that is going to make that much harder to print, but sorry. Yes, your functional lawnmower print will be a little difficult. Okay. Oh, we can't have the blades going that way. Grr. Can I pattern features? Yes, circular pattern feature. That is what I want. Select the features. Those 3, then 2, boom. There, now our blades are on the right sides. Correct sides. Perry G, thank you for the donation, man. I appreciate it. Thanks for the tutorials. What material do you suggest for portals? I'm doing a test print in PLA for my old Losi MRC. Oh, for an MRC. Okay. Honestly, PLA is pretty strong for the ability that it has. I use PLA a lot. I would maybe just tell you to stick with that at the get-go. And just see how that goes. We went to 11.5 there. One more. These are unnecessary. Should have moved on. So we have those. Sorry. Okay. Did I screwed up at some point and fused my hub to the edit feature. Oh, that was where it was. New body. Okay. There we go. Because this was our bearing and it should not have been attached. So I want that lawnmower blade to go. So 10 millimeter ID, I'm going to go 9.5. Here we go. We're just going to take that up through there for now. We're going to tie that into our engine. And that is only going to, it's going to be because I'm going to try and put like a knob on it or whatever so that you can spin it. It's dumb. Dumb. But that was the whole point of a bearing and blades. Let's go components. There. Now we can see that we've got the bearing, the blade, the shaft that will come up. How much would the guy at the hobby shop pay for this? You know what? Telling you, there's however many people that are making 3D printed scale accessories. Don't be scared of that either. Let me check something. Oh, we're doing pretty good. So, okay. We need a motor. Moving stuff around on my screen by accident. You really want to be Josh? Nobody wants to be. Just for his CAD skills, yes. All right, motor. We got to make this thing. I feel like I need to make this shaft taller for now. Not that it's going to end up being that tall, but I'm going to use it to build around. Pull start rope, man. Oh, use that to spin it. You guys are going to have to wind your own winch line. But then I don't know, you'd have to retract it somehow. Urgh, that'd be difficult. Seriously though, I've got to this whole engine thing. I'm just going to draw something and then we'll figure out if it's garbage or not. Um, 13. New body. This thing's going to need to have some sort of, oh, the discharge chute. Yes. That's another part that we definitely need to figure something out on. I also need to make sure that this attaches to the base of this thing. Hopefully I'll come up with a boss in the front maybe and put a screw through it. How many can I print and ship to you? How many am I looking to buy? I'm going to do, let's do a construction plane. We'll select the front. Just drag that thing out a distance like that. I'm going to use it as a sketch. And then I'm just going to, based on the center, we're going to make this 2 millimeters wide. P for project, grab that whole surface, create a point. And then we're going to attach those points, midpoint, and do a collinear mate there. This is mainly for detail. Objects to cut. There should only be one. Yes, there is. Hit OK. But I'm going to circular pattern. Feature. Axis is our origins axis. Let's just doing this for some sort of character lines on it. Most of this is going to get covered up anyway, but at least now there's something showing up under there. Chamfers? What are those going to look like? Unnecessary. What are your thoughts on printed truck bodies? Seem to be getting super popular. I don't like it. They're not for me. They just, that's not the type of bot. They wouldn't last for me. It's just not something that I think is a realistic option for. I don't think they look very good unless you're really good at body work, like Matt or Pardon My Noob. I think most of them look like printed bodies. You know, you have to find good designs. They're brittle. They don't hold up. They take just a ton of work. I just don't like them. You would. I can't think of the situation where you're going to end up finding me running one of those. So we are going to do something that looks like the fuel tank on this side. I'm just starting with a shape for now, and we're going to modify it. New body. Okay, let's do a chamfer on these. That. Throw a heavy radius on this corner. Come back in and then just throw a normal radius around here. Okay. That radius around the top. Uh, 1.75. Call it good. On the bottom like that. Do this two sides. Oops. That'll be something like a fuel tank. We've got the exhaust that normally goes on this side. So let's like that. I'm going to do a collinear mate just with the top, just to make sure things are where they need to be. 9 forward. I'm going to make all of these items. This whole top is just going to be kind of one Oh, we're going to make that as a new body first. I'll come back and join it so that I can add some. That. So you can see this is nothing here is based on any sort of reality. I'm just staring at a random picture and I'm not even trying to replicate it. It's just shapes that look like something similar. What are you getting the over-engineer things? Over-engineering things. That's what we're saying I'm doing? I mean, not disagreeing, but I take offense. There's your exhaust. And I guess I could make it. Oops. No. Paint it silver if you want more detail. So we got that. Now we need the shape of the top. Wait, was that? Yeah, that is the exhaust on that side, right? Oh, no, that was the. Oh, I'm sorry. That was not the. That's the intake. When am I getting my Prusa? I don't know. I have not. Just haven't decided to pull the trigger. Thinking we kind of make a round shape. Then we're going to do something like this. Allows me to right. This, I'm kind of just drawing the shape of this top portion. Hopefully it, well, oops, need to edit. I'm going to project a few of these shapes so that I can create some offsets. Let's do, actually, can I undo? Yes. P for project, and I'm just going to grab that outside edge of these. There we go. There we go. Now I'm going to offset those by 0.5 millimeter. There. If you don't connect these, okay, now let's see what this does. times. Missing. Didn't connect to the top. Here we go. Makes sense. The exhaust next to the fuel tank seems iffy. You are correct. I was mistaken on that assumption. There we go. Uh, 10. Yeah, we'll work with that. Again, this is just one of those shapes to work with. We're going to do, rather than equal distance, we're going to do 2 distance here. Allows us to drag that back while not drag that one down as much. Actually, if we just go, we don't need to go that far. Go about like that. Oh, we need a radius there. Oops. This is just trying to make things look kind of flowy. It's looking right. That's looking mower-ish. Drag that down. We got a little too much gap there. Okay, we have that going. So now I'm going to, you remember, this is a little older, but it'll be all right. I'm going to make a, so we need something that's going to allow us to spin the blade, but so it's going to need to protrude. I'm going to try and not make it look too funky, but it's not going to look perfect. And I mean, there's going to be some friction. Let's see. Ooh, I could put another bearing. 2 bearing. We need 2 bearings, right? Yeah. I wonder. If I do 2 bearings, that would fix that. $15.5. Yeah, let's just carry that down a bit. There we go. So we'll have a pocket that goes down. Oh, I'm going to make there we go. I'm going to combine those items. RC lawnmower, just a lawnmower. Is Scale News on Tuesday this week? Scale News is on Tuesday every week. So, yes. I try and stay consistent on that for that reason. I can These things can collide a little bit because they're going to print together anyway, so. That's it. Okay. So I think we're gonna have just something. The cap will fit the top of the cap will fit the top of the bearing. What do you mean? I'm gonna grab that bearing that we drew below. I'm gonna click this create a copy thing here, and then when I grab that, I can bring it up. Can't see the seat. Urgh. Oops, moving it the wrong way. I'm gonna hit cancel. I'm going to measure from this distance to, well, that distance is 14 millimeters. Close, okay. So if I click that, create a copy, I believe I can just go up 14 millimeters. Hit OK, and I think if I do a cross section, section analysis, yes, everything looks correct. Okay. Can someone update me on what he's making? We are making a push lawnmower. For some, we started with the idea of a project earlier, which was for drag cars, and we completed that, and then, but it was a little bit frustrating. So we decided to do something slightly ridiculous and a little bit entertaining. So, lawnmower blade on a bearing will go up through a shaft through that bearing, two bearings on our lawnmower, 10 by 15 by 4s. And now we need a top part that will allow us to spin this whole thing. So we're going to do something like outside needs to be like 13 so it doesn't ride on the outer race. Inside 10.5. It's pretty thin right there, but it should be all right. Let me see if sorry, section analysis again. I was right at touching. So I'm going to bring that back off a 1/2 millimeter just to give us. So we're going to go -1.5 total. I'm going to hit P for project on that surface and the inner. Now I'm actually going to change that inner bore on that bottom part rather than so that we can make a screw hole from the top. Something like that, 2.5. We're going to do new body, but then I'm going to combine it with that other lower portion first. A for appearance. I'm going to duplicate, edit. Good idea. Let's save. Saving. Now, we're basically just I'm gonna put kind of the disk is technically going to hang over top of some stuff. It's not the sexiest of solutions, but you want spinning lawnmower blades or not? Let's do a pattern on the top to make it look somewhat. Oops. I'm gonna do a line that connects those, and then a line to connect. I'm gonna do an even. Let's do 15 degrees. No, we'll do 20 degrees. If I do that, I can pattern it around an exact amount, and things will stay even. Do all of these equal, and we can define that as 1.75. Three is fine. Oh. Let me. I don't know what. Has this got some sort? I don't know. Okay. Circular pattern. We're going to select those items. Center point here. 20 degrees, so 360. 8. Let's see. 9 times. Hit OK. Ugh. Should have done that. I should have done the cut and then the selection, so I didn't have to select this many circles. Oh well. We've gone this far. Slots wouldn't be bad. I mean, they could have. It's just a difference. I don't know if one's better than the other. They both are pointless. Oh, that is going to suck on it. We're just going to go 0.4. Ridiculous. You can type an equation to the you can type in equations to the dimensions. Yeah, you can do all kinds of yeah, like 360. Yeah, you can do all kinds. You can actually name dimensions as parameters, and then it'll automatically build you a chart, and you can adjust all kinds of stuff. There's some fun things you can do with that, but that seems like a different day. Okay, we need to, well, for one, we need to be able to attach this thing. So let's do I'm gonna hide that body first. Let's hide that one. Now let's do a sketch on this. .5 there. 6 here. Now 10 is good. Of course, there's some interference. This is going to be to catch that. Now I need to put a D 3.5 here. Finish sketch. We're going to select the cuts, drag it down, and turn that body back on. That gives us that cut. So now we should be able to put a screw up through the bottom and hold the motor into place. It's only one screw, not the best, but make it a left-handed start. I mean, seems like a starter cable is, you know what, that might have to be on, your imagination. We need to put a handle on this thing, and maybe we'll see if we have time for anything else. It's 8:15. We're 2 hours and 15 minutes into this whole stream. Granted, I think we've only been working on this thing for like an hour, but still, we've been working on a riding lawnmower for an hour, or a riding lawnmower, whatever this thing is, push mower. I'm working on the handle right now. And I'm just creating a plane to kind of give me an area. 17 is fine. I need an area to attach it to. That's and then I have to figure out how we're going to attach it. Let me think. $10mm up. Uh, 15. Doesn't cut into anything, so. Throttle cable. You got, what is wrong with you guys in these suggestions? Handle idea. Make 2 slots for a paper clip or other wire to key into at an angle. That would work well if you wanted it, but I think it'd get pretty long, like for how long this thing would need to be. So I think that you'd end up having to have something, you'd have to like cut up a coat hanger, which you could do if you have a wire coat hanger. I'm gonna try and make something that you can print just because it'll be easy. A lot of people don't want to do anything extra unless they can just hit print on their computer. So we're gonna do that, but I think a wire coat hanger would probably make for the best looking one. Will the wheels be adjustable to make sure the grass cut to the height is just right? No. My height is the height you get. No soup for you. I am going to put a that's going to be a 2.5. And a 4 screw. That. I haven't seen a wire hanger since my grandma's house. I know, like everyone's just, I think all mine are plastic as well. Does the blade have clearance for motor mount screw? So current, I need to, that's what I was going, the screw is going to go from the top down in through the bottom. I need to make that adjustment. So let's do that before I forget. I'm going to just do a and this really doesn't actually have to go all the way down. There. So now you'll have an M3 screw go down in through that. It'll go. Let's do, I'm going to put a 1.7 millimeter. That way you can use a flathead screw in it. And that's how you'll spin your blade. What's the why? So we're gonna do that. Now I'm going to hit P for project, grab that whole surface, do a 3.5 there. And gonna dimension 0.5 up. New body, hit OK. I'm gonna make another. Needs a neighbor kid to pay to use it. Yeah. So let's do a how tall is it? What is it? What's the height of a handle normally? Is it like 36 inches off the ground, you think? 3 point. Whoops. 3.6 inches. Not Jesus, that's tall. Whatever. Let's go a little lower. Let's go 3.25 inches. Right. And let's turn this into a construction line. Pretty sure I forgot that I was on a live stream there and just started drawing. Just zoning out, drawing a freaking lawnmower. So I'm really just trying to four there. Okay. I'm going to, oh, okay. Actually, finish, check. Join those. I'm going to do a fillet there. Connecting like that, but I'm going to just going to do a I'm creating a what will become like the stop for the arm so that it doesn't want to just fall. It should kind of do that here, but I don't 100% trust it, so that's why I'm creating one here that will just go to, oh, can't go to a midpoint. Okay, I'll just go, I think I'm good there. One, there we go, perfect. All right, we're almost there. Home stretch, because we're not going to go into crazy detail in the rest of this thing. Sorry, not sorry. For there. Gotta find the midpoint. Four. Think that will do there. We can do up here, let's do like a 8mm radius on the inside, and we'll do a 12 on the outside to give us that curved look. Now I'm going to mirror this body around that plane. Or just to double check, we'll do it around the right plane. Same. Okay. same thing. We need to mirror the mount. And I'm going to combine it. And then we can do some more filleting to make things look there. Actually, it doesn't want to fill it very well, but we'll see where we can make it work. Plastic lawn furniture next. That even, God, the thin, anything that gets super thin is what makes everything so difficult. So we got all that. I think we are about where, there we can go. That worked. We're gonna do one more on the other side, but I think we can call this thing done. Great, now I have to build a scale shed. Oh my God. So we did a ridiculous scale lawnmower for no good reason other than the lawnmower is not complete without a gas container. We don't have time for that. It is 8:30 here. Complete with spinning blade, dual supported bearing lawnmower. We're gonna have a bit of an issue there. Unless I do. If you put a screw in here, it is going to hit. You're not gonna be able to tighten it up without without hitting the bearing. So I just need to put a small boss around it. $1.5. Although you could also, while it should 1.25. Anyway, it'll also could help keep it in there. So the head of it would just barely overlap. Still needs the HD logo. Oof. This one's going to be tiny. Let's do create text HD impact font. Hit OK. Fits 6. We can kind of overlap it like that. Two sides. Up 0.5. There. How about that? Clipping shoot. Ah, this is a mulcher only. God, you guys are killing me. All right, you guys don't. I guess if anybody doesn't want to watch, they don't have to be here, right? I mean, most people have left. We've seen that. Okay, so 7 over. We'll do 14 total. 2.4 up from the bottom. And we'll do 7 tall. Since we have to cut a hole. Now let's make a fillet to open, make it look decent. All right, now this part's kind of tricky. That doesn't have to be. I have an idea. Right plane. We're just going to do something like this. Let's just throw a line like that. Let's see if this works. Oh yeah, we need that. New body. We'll go 16 that way, and then we also need to do 2 sides, and then the other side we need to go 2. And then we're going to do a shell. I'm going to select those 2 faces. We're going to do a thickness of 2. Oh wait, I'm going to modify, edit. Select faces. Oh, wow. Shell, one more time. That face, and that face, 2. So we got those all done. Now we can do a combine, but we don't do it. We do a cut target body, this tool body, the body, and we keep the tool. Hit OK. Haha, success. So we have that left. Let's turn off all this other stuff. Thought I had that left over. Oops. Nope, won't let me do that. Just doing this the cheater way. Wait. Okay, so we got that. Actually, let's do a chamfer. Hit OK. And we need to be able to, you get a fillet, you get a fillet. Look under your chair, fillets. That is a very base gas ejection chute, but everyone had to get one. And we should probably look at being able to retain it. Oof. I feel like this is a shoe goo component. I feel like a piece of hardware is way too big. I don't like it. Glue it on. That's what I think of that. Right? Right. I think we're done. Grass clippings bag on the back. No. Not a chance. There you all have it. We need... There. We're filled in one side, so it'll still print flat on the bottom, but at least it looks a little bit better on the top. Save. Good idea. 949. Won't that bolt on the bottom interfere with the blade spinning? I think... Oh! I thought that I had enough. I had enough room before I added more space. I have 1.75 millimeters. That's like right at enough space. Like just. Just at enough space. Technically, it'll fit. Maybe I'll modify it slightly off stream, but yeah, like someone says, glue it. Glue the top on you. I think I'll make it work. If I have to make a little modification, maybe I'll do that real quick before I upload it. But that is where we're going to call the live stream because most people have left anyway. So if you hung around to watch this full thing, this whole deal, thank you for joining me. I appreciate it. Live or on recording, if you did, let me know. These are, you know, just kind of for the sake of being ridiculous. And I realize I have this big flat surface here, but it won't really lay flat because of the design of this thing. It's not the most efficient design, I'm not gonna lie, but it's a lawnmower, so yeah, there we go. I'm calling it. Countersink screw. I thought about that, but I don't know if that'll interfere with the bearing or not. I mean, it might still work. If I go... It's going to interfere at some point. If I go 0.75, you might be able to use a countersunk screw. You'll get away with that just enough. You'll have 3/4 of a millimeter, and if you actually, there's a 1/2 millimeter of play at the top, so the whole thing will go down a 1/2 millimeter. It'll actually be all right. So even if I only split the difference, if I select this whole thing and move it, oops, let's see, set pivot on this, hit OK, and then I go down by a 0.25 even, just splitting the difference between the play that I designed into the top and at the bottom, should be all right. Or let's, yeah, I mean, I'm just gonna do a section analysis. So you can see I have play here. I still have this. So I actually have, it can even come down a little bit further. Everything should still clear. There should be enough play for the bearings. Yeah, we're good. I left enough that it I left enough for it to move around without much of a concern. One screw in. A lawnmower, scale lawnmower with bearings. And can I... There we go. Done and doneer. Thanks again. Let me know if you guys watched this whole thing, live or not. Appreciate it. Drop a comment. Hit the like button. I'm tired from talking so much. Later, guys. Thanks again. In-store credit if it doesn't work. God, you guys are killing me. Later. Talk to you guys next time.